everyone, thank you so much for coming to this video. So today we're going to be going over how to evaluate definite integrals. So make sure you review the videos on normal integration, as that will come into a lot of use for this video. So the learning objective for today is to be able to evaluate definite integrals, to be able to use a definite integral to find the area between a curve and the x-axis, and to be able to use a definite integral to find the area between two curves. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So if we start off with the first learning objective, to be able to evaluate definite integrals. So firstly, you just need to know what a definite integral is, and that's just one that is an integral limit, such as here we have 3 and 1, and you just want to find the integral of your function at those limits. So for this one, you want to find the integral of x squared plus 2x between 3 and 1. So 3 and 1 are your limits. So to do that, I've written out the 3 steps here that you need to know. So the first step is you just want to find your integral in the normal way, and then you want to use your limits after. So you just integrate your x squared plus 2x normally as you would normally do. And you then put your integrated function in square brackets and you rewrite the limits on the right hand side, and then you just do your top limit. So you evaluate your function, so you plug in your limits of what you get as your integral, and you do your top limit minus your bottom limit. So it'll make more sense if we try this out. So the first thing, we just want to integrate normally. So if we integrate x squared, remember that you add 1 to your power, so you do 2 plus 1 is just 3, and you divide it. So you would get x cubed over 2 plus 1, so over 3. And then plus, if you want to integrate 2x, your power is 1, so if you add 1, you get x squared. And then if you do 2 divided by 2, you'd just be left with 1. So your integral is just x cubed over 3 plus x squared. And then here, because it's definite integrals, you've got 2 limits. You don't add your constancies, you don't need it. Instead, you just use square brackets like this. And you evaluate it, and you rewrite the limits with 3 at the top and 1 at the bottom like that in your square brackets. And then you want to evaluate the integral at those 2 limits, and you do your top limit minus your bottom limit. So if you plug x equals 3 in first, you'd get 3 cubed minus 3 plus 3 squared. So that's your top limit minus your bottom limit. So it's just 1 minus 3 plus 1. And then if you plug that in your calculator, you should get that as equal to 38 over 3. So that's just how you evaluate definite integrals. Just integrate it normally, put your square brackets with your limits on the right hand side, and then you plug in your limits into your integral that you get, and you do your top limit here minus your bottom limit here to get your answer. So that's how you evaluate definite integrals. Now let's move on to how you can use this to find the area between a curve and the x-axis. So definite integrals just give you that they can also give you the area between the curve and the x-axis. So for example, what we just did when we were finding the integral of x squared plus 2 between 3 and 1, that's just the same as if you were to draw the curve x squared plus 1 as I've done here. It's just the area between the x-axis, where x is equal to 3 and 1, and the curve. So it's just that blue shaded area there. So that blue shaded area is also equal to 38 over 3. So that's just how you can use definite integrals to find the area between a curve and the x-axis. One thing you do need to be really careful about is if you have an area that's, if you draw your diagram, you have an area below and above your x-axis. So for example, if you have the integral of x cubed between 2 and minus 2, as I've drawn out here, you have a blue shaded bit between 0 and minus 2, that's beneath the x-axis, and you have an area between 0 and 2 that's above the x-axis. So that means that your negative value below your x-axis and your positive above, that will just cancel out and you get 0. but that's not the actual error. So you need to do something about it to make sure you don't make that mistake. So let's just see how you would actually get 0. So if we were to integrate this normally, we would get the integral of x cubed, you add a power, so 4, so it'll just be, and you divide that, so you'd get a quarter x to the power 4 between 2 and minus 2. And that would just be so a quarter times 2 to the power 4 minus a quarter times minus 2 to the power 4. And this would be equal to 4 minus 2 to the power 4, that's 16 over 4. So that would also be equal to 4. So therefore you'd get 0. So to do this, you want to split up your integral. So you want to integrate firstly between 2 and 0 of x cubed dx. And if you do that, you'd get a quarter x4 between 2 and 0. So that's just a quarter 2 to the power 4 minus 0. So that's just equal to 4. And you also want to do between 0 and minus 2. So you want to split it up. So you're going to split up your positive bit and your negative bit. And if you do that, you'd get a quarter x to the power 4 again, between 0 and minus 2. That would just be 0 minus, if you plug in minus 2, you'd get minus 4, so that's just minus 4. And then if you were to add it, so you can take your absolute value of your negative 1 to get 4. So then all you do is just do 4 plus 4, and you get 8. So that's the total area between your curve and the x-axis for x cubed between 2 and minus 2. So just remember that if you have a negative, if you have something that's below the x-axis and above the x-axis, you need to split this up to make sure your negative and positive areas don't cancel out each other, because remember, you can't have a negative area. You can only have a positive value for an area. So we have an exam style question here. Feel free to pause the video and try it out for yourself first. So we have the curve y equals x minus 2 squared, x plus 2. It's shown in the diagram, and we want to find the area bounded by the curve and the x-axis for the curve. So we want to find the area between the curve and the x-axis. So we want to find this area here. And as you can see, all the area is just above the x-axis, so we can just do this in one go. So we want to find the values where this curve crosses the x-axis, so that we want to find it between 2 and minus 2, and that's of x minus 2 squared x plus 2 dx. So we want to integrate this equation of the curve between 2 and minus 2. So the first thing you want to do is you want to simplify this out to get some values that will make it easier to integrate. So if we do that, so that's just the integral between 2 and minus 2. So first expand x minus 2 squared, so we'd get x squared minus 2x, so minus 4x plus 4, and then all multiplied by x plus 2 dx. And then we can further expand this out, so we'd get 2 between 2 and minus 2, x cubed, x squared times 2 plus 2x squared, minus 4x times x, so minus 4x squared, minus 4x times 2, that's minus 8x, 4 times x plus 4x, and then 4 times 2 is plus 8 dx. And then we want to further simplify this, so we get 2 between 2 and minus 2 and collect the like terms. So we'd have 8 cubed, 2x squared minus 4x squared, that's minus 2x squared, minus 8x plus 4x, so that's minus 4x, plus 8 dx. And now we can just integrate this normally and put it in squared brackets. So x cubed integrated, that's just a quarter x to the power of 4, minus 2x squared integrated, that's just minus 2 over 3 x to the power of 3, minus 4x integrated, that's just 4 over 2, 2x squared, and then 8 is just plus 8x. And you want to do that between 2 and minus 2. And then we want to plug in the values and do top minus bottom. So we'd have quarter times 2 to the power of 4 minus 2 over 3 times 2 to the power of 3 minus 2 times 2 squared plus 8 times 2 minus a quarter times minus 2 to the power of 4 minus 2 over 3 times minus 2 to the power of 3 minus 2 times minus 2 squared plus 8 times minus 2. And now if we were to plug this into our calculator, we would get 20 over 3 minus 44 over 3, so 20 over 3 plus 44 over 3, and that's just equal to 64 over 3. And that's our answer to this question. So yeah, if you have the curve here, you want to find the area bounded by the curve and the x-axis, you just do your integration normally, with your limits being where the curve crosses the x-axis. And because it was all above the x-axis, we can just integrate it normally. We don't have to split it up. So yeah, that's how you use definite integrals to find the area between a curve and the x-axis. So now let's move on to how to use this to find the area between two curves. So you may also be asked to find the area between two curves like we have here. So we want to find the area enclosed by the curves y equals x squared plus 1 and y equals 9 minus x squared. So in order to do this, the first thing you want to do is you just want to draw out your two curves on the same axis to see what the area would look like between the two. So if you were to draw x squared plus 1, we would get the curve looking like this, and 9 minus x squared, the curve will look something like this, this being 9. So therefore the area that we want is the area between here, and we want to try and find, the first thing we want to do is after this, we want to find out what these two x coordinate points are, as we'll need that for integration. So to do that, we can just find out where the two curves intersect. So where x squared plus 1 is equal to 9 minus x squared. So that would just be 2x squared is equal to 8, x squared is equal to 4, so then x is equal to plus or minus 4. So then we have this is equal to minus 4 and this is equal to 4. So now that we know this, we can figure out how we could use integration of the two curves to find this common area. So if you think about it, if we were to do the area, if we were to integrate, let's start with our y equals 9 minus x squared curve between 4 and minus 4, we'd get the whole area between the curve and the x-axis between 4 and minus 4. So that will be this whole area here. And then if we were to integrate y equals x squared plus 1 between 4 and minus 4, we'd get the area beneath your curve, y equals x squared plus 1 between 4 and minus 1. So we'd be left with this area. So then if we were to do this, if we were to see the red area, this whole red area, and then we minus this green area, we'd be left with the blue area here. So therefore, in order to find the area between the two curves, we can do the integral between 4 and minus 4 of 9 minus x squared minus the integral between 4 and minus 4 of x squared plus 1 dx. So if we subtract the area beneath your 9 minus x squared, if you do that minus the area below it, x squared plus 1, you would be left with that enclosed area. So now we can just solve that. So if we start off with the area between 4 and minus 4 of 9 minus x squared dx. So if we integrate this normally, we would get 9x minus a third x cubed, and then we can do that between 4 and minus 4, and we get that is equal to 9 times 4 minus a third times 4 cubed minus 9 times minus 4 minus a third times minus 4 cubed. And then if we plug that into our calculator, we would get that is equal to 46 over 3 minus 46 over 3. So that's just equal to 92 over 3. And now if we were to do the area between 4 and minus 4 of x squared plus 1 dx, that would be equal to, if we integrate this normally, add 1, so and then divide, so we get 1 over 3 x to the power of 3 plus x between 4 and minus 4, and that would just be equal to a third times 4 cubed plus 4, subtract a third times minus 4 plus minus 4. And again, if we were to plug this into our calculator, we'd get that's equal to 14 over 3 minus 14 over 3. So that's just 28 over 3. So now if we were to subtract the integral of 9 minus x squared, so that would be equal to 92 over 3 minus the integral of x squared plus 1 between 4 and minus 4, that's minus 28 over 3. We would get that is equal to 64 over 3, and that's our answer. So that's how you find the area enclosed by the two curves. So to do we just want to draw out our two curves, and then we want to find the values where they intersect, and then we can work out if we need to add any curves or subtract any integrals to find your common area. So for this we did the area beneath the curve 9 minus x squared between 4 and minus 4, and then we subtracted the area beneath the curve x squared plus 1 between 4 and minus 4, and we just did the normal definite integrals and just subtracted 2, and we got 64 over 3. So that's how you do that. So we can also apply this to parametric curves, so let's try that next. So we can also apply definite integration to parametric curves. So the formula that you need to learn for this is if you had two parametric curve written in the form with x and y in the form of another parameter t, then in order to find the integration of y of dx, you just do the integral of y times dx over dt times dt. So that works because if you crossed out your dt, to simplify that, you'll just be left with y dx. So that's how you would do parametric integration if you have curves written in parametric form. So if we try it with this question, we have x is equal to t cubed plus 1 and y equals t squared plus 2t plus 3, and we want to find the integral of y dx between t equals 1 and t equals 0 and t equals 1. So that's the same as if you draw that curve, the area between your t equals 0 and t equals 1. So to do this, we can use this formula. So the first thing we need to find what dx over dt is. So our dx over dt, that's just if we differentiate our x, we'd get 3t squared plus just 3t squared. So then if we do the integral of y dx, so that would just be the integral of our y, which is t squared plus 2t plus 3 times 3t squared, and that's between 1 and 0. And now we can just multiply this out and integrate normally using our values of here and our normal integration. So if we multiply this out, we'd get between 1 and 0, 3t cubed plus 6t. So 3t to the power 4 plus 6t cubed plus 9t squared. And then that would just be equal to, if we add 1, we'd get 3 over 5, t to the power 5, plus, if we add 1 to the power, t to the power 4, so we'd get 6 over 4, which is just 3 over 2, t to the power 4. Then we do add 1 to this power, so t cubed, so it would just be plus 9 over 3, so that's 3t cubed, and you want it between 1 and 0. Then if we were to plug this in, we'd get 3. First we plug in t equals 1, so we get 3 over 5 plus 3 over 2 plus 3 minus, if you plug t equals 0 into all of that, you just get minus 0. And if you were to plug this in your calculator, that would just be equal to 5.1, and that's just your answer to this question. So whenever you ask to find the integral of like a parametric integration, all you do is you just find out, you use this formula that the integral of y dx, that's just equal to your integral of y times dx over dt times dt. So that's because you have your y in the form of t. So in order to integrate this, you have to integrate with respect to dt. So that's why we found what dx over dt is. So we did y times dx over dt, and then we integrate that with respect to dt. And then you just plug in your values of t and you just integrate this normally to get your answer. So that's everything we needed to cover. So let's just try one exam question to see if you can apply definite integration. So we have an exam question here. Again, feel free to pause the video and try it out for yourself first. So we have the diagram above shows a sketch of the curve C with parametric equations x equals 5t squared minus 4 and y equals 9 minus t times 9 minus t squared. So the curve cuts C at the x-axes at the points A and B. So the first thing we want to do is find the x-coordinate at the point A and the x-coordinate at the point B. So we know that if it cuts the x-axis, that's when your y equals 0. So the first thing you want to do is you want to find t when y equals 0. So we can do that. So we can say 0 is equal to t times 9 minus t squared. So you have two solutions. One is when t equals 0, and another one is when 9 minus t squared is equal to 0. 9 equals t squared, so then when t equals plus or minus 3. Then we can plug our t values back into x, so we have x is equal to 5. So first when t equals 0, 5 times 0 minus 4, so that's equal to minus 4. And then we also have x is equal to 5 times 3 squared minus 4. So we have 5 times 9 minus 4, let's say 45 minus 4, so that's just 41. So if you were to do minus 3, you'd get the same answer because 3 squared and minus 3 squared is the same. So therefore you have your A, that's the coordinates is minus 4 and 0, and you have your B with your coordinates 41 and 0. So now your next thing you want to do is, for part B, you have the region R as shown shaded in the diagram above is enclosed by the loop of the curve. We want to use integration to find the area of R. So we want to find the area, using this, we want to find the area of between, you can use T because everything is in T. So our T values between B and A, that's just 3 and 0, so between 3 and 0, of our Y, which is just T times 9 minus T squared, and we want to do dx over dt times dt. So now we just want to find what dx over dt is. So dx over dt, that's just equal to, if we differentiate 5t squared minus 4, the derivative of 5t squared, that's just 10t. and the derivative of 4 is just 0. So then we want to find the integral between 3 and 0 of t, 9 minus t squared times 10t dt. And we can simplify, say that's equal to the integral of 3, 0. So first, if we do 10t times t, we would get 10t squared, and then times 9 minus t squared dt, and that would be equal to the integral between 3 and 0 of 9t squared minus 10t to the power of 4 dt. And if we were to integrate this, if we add 1, we get to the power of 3, so 90 divided by 3, that's just 30t to the power of 3, minus, if we add 1 to the power of t to the power of 4, we'd get 5, so 10 divided by 5, so minus 2t to the power of 5, and then you want that between 3 and 0, so that would be equal to 30 times 3 cubed minus 2 times 3 to the power of 5, minus, if you plugged in 0 as t, it would just be minus 0. So then if you plug that in your calculator, you should get that is equal to 324. So that's your answer to this question. You get that is equal to 324. So if we flick back to the diagram, you can see that you have both an area above the curve and below the curve. So we've worked out 324. So that is just one of the loops that's above like the x-axis. So because if you remember, our b value, that's at either when t is equal to plus or minus 3. So what this integral that we just did, that's between 3 and 0. Now if we were to do the other one, so that we just get the one above the x-axis. So now if we were to do between 0 and minus 3, we'd get the area below the x-axis. And as you can see, they're just equal. So to find the total area of R, you want to times this by 2. So then you can just write the total area. That's just equal to 2 times 324, and that's just equal to 648. So that is our final answer. So yeah, it's easy to make the mistake of leaving your answer as 324, but you need to remember that the b coordinate that we got, that's for both for t, which is plus or minus 3. And if you see on the diagram further back, you have the area of R is above and below, but they're equal. So it's just the same as finding the area between 3 and 0 and minus 3 and 0. So you just work out the area between 3 and 0, which is 324, and you just times that by 2 to get the whole R, to get 648. So yeah, that's everything. Again, just remember to use this formula when you're doing parametric integration, and just apply that to any thing that you get. So that's everything. Thank you so much, everyone. Hopefully you found that useful, and you can now evaluate definite integrals, and you can use them to find the area between a curve and the x-axis for both normal curves and also parametric curves, and also you can use definite integrals to find the area between two curves. So make sure you do some practice questions just to make sure you understand everything that we've covered.